Hi, welcome back to part two of sedimentary rock and fossil fuel formation, right? What are the processes that led to the formation of sedimentary rocks and fossil fuels? So remember, we made this from part one and we labeled and we labeled it in our science notebook, right? We used whatever we had in our house. We are not doing anything with it. This goes in the before picture. Before I go into part two, I want you to think about this, okay? If I showed you two different sponges, okay, these are two different sponges. They're from my kitchen. I cut them into smaller pieces, they were big. Now, if I take, look how fluffy they are, okay? Look at that, okay? And same here, how loose they are, right? Standing nice and puffy. Look, they're porous, they have a lot of holes between them, a lot of air pocket spaces, right? Taking up a lot of space in the container. Think about it. What would you see? What do you predict you will see if I were to apply pressure? If I were to keep it like this, right now it's very fluffy and very widespread, right? What would happen if I were to apply pressure on it? What would you see? What would happen to these two layers of sponges? So pause for a second and think about it before I show you the results. I'm sure this is what you must have discussed or this is what you must have predicted. Watch what happens. I'm going to add weight to it. Now, this is heavy, but watch what happens to these layers, okay? See if it stays the same thickness or anything else happens. Pressure, 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 compression, 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 compression. Okay, what's happening to that layer? I bet this is what you predicted, right? That the layers become very, very thin. They become very small or thin. You can hardly see them. They're not as fluffy. See, they were fluffy like this, but when you compress, meaning apply pressure from the top, and there's nowhere else to go for it, because at the bottom also it's squished, right? And so you see this thin layer forming. This is called compression. And when you press down, that's compression. And when it becomes thin layer like this, that's called compaction, compact. Okay, so we're going to see what happens when we apply the same type of pressure to our model. Imagine many, many years ago when these layers were formed. Now, we created this in the labs, so you can't see the pressure that this layer must be experiencing. Imagine millions of years ago, for millions of years, the other layer is forming, and imagine the mass and the pressure from the top that's coming on the bottom layers, right? Every time a new layer is forming, the bottom layer, the bottommost layer is getting squished and squished and squished. It's experiencing more pressure, and that is called compression. So you are going to now do part two, meaning use the after picture and see what happens. You saw what happened to sponge, the sponge that I used for my kitchen. That kind of gives you an idea, right? They didn't just sit there. As they started collecting, they started exerting pressure towards the bottom layer, on the bottom layer, okay? And that is called compression. So I'll show you, and you're going to mimic it. You're going to mimic it by putting your fist in the other empty cup, okay? And you're going to stand up, make sure it is in a safe place, and you're going to push on it, push, push, push on it as much as possible. The more force you apply, the pressure you apply from the top, the more it's going to stick. Imagine in the real world how much pressure, how much compression must be happening from the top. So now you can see I actually sprinkle some water, like very little water on the top. So you can see how it has become squishy, and see all the layers, they were still here. Remember when they were nice and fluffy? Now when I applied pressure from the top, it became so compact. See, the size went down, it became compacted. The compression from the top created compaction. Okay, and imagine the pressure that this layer must be experiencing because of all the top layer pushing down on it, right? So that's what you're going to draw in your notebook. Okay, I'm sure this is what you also observed, and this is what you're going to draw. Okay, so I'm going to draw it too and be right back. Now think about it. What was the pressure that we were applying from from the other cup? What does that represent? That represents the pressure that each layer is facing or is feeling, is experiencing from the top layer. Every bottom layer, this is the oldest layer. Which one is the oldest layer? This one is the oldest layer. Okay? Imagine, think about it. What does the oldest layer represent? How do you know this is the oldest one? Because it is at the very bottom. If you were starting to dig from the top, you will hit that the very last, right? So that is the oldest. The top, what is the youngest layer? What is the newest layer? That's the topmost layer. So the newest, and then the second one, the third one, and the last one. So this was the oldest. Okay, this is what is your coal. This becomes coal. Okay, how does this become coal? How does the ancient swamp soil, dead, decaying plant matter, and some animal matter become coal is when it experiences intense pressure from the top. Think about the situation, okay? It's experiencing pressure from the top, and then it doesn't have any place else to go. It's getting squished and squished and squished, and it compressed and compressed and compressed. That process is called compression because it's experiencing pressure from the top. Okay, and it is also getting heated because press down on your palm and notice what you see. Okay, press down on your palm for some time. What do you start feeling? Right, heat, right? So when you press down on something, when layers press down on something, then they start experiencing heat. Not only from the top are they pushing down and it's experiencing heat down here, but the bottom of the earth, the center of the earth is also hot. So heat is coming from there as well. So intense pressure from the top is creating heat, and the core of the earth is creating heat. So that compression and the heat is kind of baking each layer. Okay. And so that is called compression. Second thing that happens in the process, the second process that happens is the compaction. You saw how large the layers were, but as you compress and it gets heated and it gets cooked and baked, kind of, then it's getting compacted. The big size is getting smaller and smaller and smaller. Think about your suitcase. You're planning a vacation somewhere. Your suitcase is open. You're going to stuff all your stuff. Your mom says, we're going to Hawaii. You want to stuff whatever you can carry, right? Because you don't want to leave anything behind. But now it doesn't fit in the suitcase. So now you push down on it so that you can fit everything in it, right? And then that is called compression. And then somehow you're able to you manage to close the suitcase. That's called compaction. It gets a shape, which is thinner. It's not as fluffy anymore. Okay, so that is called compaction. Think about all the compact cars. Okay, so they are becoming smaller. The third process that happens is because of this intense pressure and the heat from the top and the bottom, it gets kind of baked. Okay, it starts oozing out like things, and it has some moisture in it, so it kind of glues the sand particles and clay particles together and the organic matter together. It goes through changes. Okay, and over millions of years, this process is over millions of years, and so it starts to stick together, and that is called cementation. Okay, so I call it the three C's. I call it the three C's: compression, pressure from the top, intense pressure, okay? And then the heat that is generated because of that pressure from the top and the heat from the center of the earth. So compression, pressure from the top, that's number one. Compaction, because of all the pressure, the size goes smaller and smaller and smaller. It becomes very packed, compact. Layer becomes thin and have a definite shape now, right? And cementation, when things start oozing out, it starts sticking together like a glue. Now they cannot be separated. They are becoming harder and harder solid. That is called cementation. The three C's: compression, compaction, cementation. These three processes lead to the formation of this matter that is here. This is all sedimentary rock. This has become now a solid rock. It's baked in pressure and heat under its own weight, and because of all the heat from the bottom. Okay, it gets baked and cooked, and it's like a thick piece of solid rock now. So that is sedimentary rock for you. That's a model. Okay, that is the process, millions of years process that we created in a few minutes. And then this one here, this is what is called coal. Okay, this is the fossil fuel. This organic matter uh, is actually what we go down, we dig deep down and we extract this, we remove this. And this, because this is um, from the remains of plants, this is coal. Okay, the three fossil fuels, coal, oil, and natural gas. This is coal. And this is, we use this because this is so rich in carbon. Remember carboniferous trees? All those trees that died long, long, long ago and changed, went through this process of compression, compaction, and cementation with the sedimentary rocks. They changed. Now they become this packet of energy, that packet of carbon that you can use to burn. And we use them essentially to burn, to create electricity and to heat our homes and things like that. So we use them extensively. They're very important to us. But think about it. Why do we call them renewable energy, non-renewable energy? Non-renewable energy, because think about it, how many years does it take, and how much is earth able to produce? Look how many sediments went in there, but how much are we getting here, right? And if these many years are required to create a tiny amount of coal, then do we have enough if we keep on using it? We keep on removing it from earth and using it without giving it time to replenish. What will happen? So think about it. Why do we call that a non-renewable energy? Okay, so this is how coal is formed. How is oil and natural gas formed? Exactly same process, exactly same process. However, in that case, we're talking about more pressure. So you think about it, ocean, on top of it will be ocean. Okay, a huge ocean is sitting on top of these layers also. So the pressure of that water also goes on top of these sediments. And oil and natural gas is not formed because of swamps, because of plants. They are formed because of small microscopic animals that lived many, 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 many millions of years ago in the ocean. They fall down, they die, they fall down in the very bottom of the lake, of the ocean, with other sediments, and the same process of compression, compaction, and cementation creates natural oil. So they go through more than cementation. Cementation is when it becomes solid, right? This one is like it becomes liquid. It's experiencing so much pressure that it doesn't even stay solid anymore. It just becomes like it becomes fluid, right? And that is how oil is formed, because of the pressure of the ocean. Once upon a time, there was ocean, if not now. Okay, remember, landforms change, and oil is sometimes even compressed more, and it turns into gas. Out of that comes gas. So these natural gas is usually found near oil reserves. Wherever you have oil reserves, you will find natural gas reserves as well. And gas is formed on the top surface, a little higher, because gas has a tendency to float up, right? So you will find gas here and you will find oil here. So slightly like close, but they're on a different level, okay? But natural gas and oil are formed because of the compression, compaction, and cementation of microscopic marine animals. Okay, they were animals, they were not plants. Okay, they were animals that could produce their own energy, like zooplanktons and phytoplanktons. So those animals died long, long, long ago, and they helped create oil and natural gas. However, coal is produced when dead decaying plants from the swamps, from 300 to 360 million years ago, went through the process of compression, compaction, and cementation within the sedimentary rocks and turned into coal. Okay, so this is how these three processes lead to the formation of coal due to plant organic matter, and oil and natural gas due to marine microscopic animals. I hope you enjoyed it, and I hope you have all the information to fill your worksheet. Thank you.